Hello everyone, this is Lucas, and today we're going to talk about some data structures. As you can see here, linked lists and arrays, or as the title is, linked lists versus arrays, advantages and disadvantages. This is what we're going to talk about today, and yeah, we're going to start right into it. So first of all, an array is probably what everyone here knows. It's basically, or you could imagine it like a box that holds information of any type, may it be a string, so sentences, characters like letters, or numbers, or any other type that you may come up with. I mean, float or double, whatever, are also different types, are numbers, but are not integers. So yeah, and an array is, well, a good thing if you want to have random access to elements by an index. So imagine you have that box and you want to access an element out of this box. This box has to have a number or an index that you can use to actually get the value of that position. Another thing of an array is, well, the space for an array in memory must be set beforehand. That means that in modern programming languages, if you just create an array without telling how much is actually going to be in there, that means that it will just create or will make space for an array but automatically, and that's not really good, because as you can see in the next point, if an array is too full, it will be copied over. That means the computer is going to make more space for you. So if you need more elements in there, it will just create another, space for you in the memory and will copy over what is already in the current array because the space is not big enough there. And the removing is expensive in an array. That means, imagine you have an item in an array and you want to delete it in the middle. That means, and that's pretty stupid, if you remove it, well, all the elements in the back of it, so everything that follows that element has to be repositioned by -1, and that's quite expensive to do. So now that we've talked about the array, and probably everyone who is actually on this channel knows kind of what an array is, let's have a look at linked lists, which is something that I actually didn't know when I started with Swift, for example. So by definition, what it's holding is nodes, and a node itself has a value and a pointer. So a pointer basically is like an arrow, you could imagine it, that just points to the next element in your linked list, or to the previous one, comes up with which linked list you have. And it's preferable for adding and removing elements anywhere. That is because, well, you just have to rearrange the pointers of all the elements of all the nodes in the linked list, and we're going to look at that in a second. And well, as you can see here, it works with pointers. That's the advantage. But a disadvantage of it would be, or I don't know, the way you just want to look at it, just a fact about it is that no random access means you can't use an index number to actually get to a certain element in the linked list. That just doesn't exist here. But yeah, well, there are just those two types really that you can compare here. That means one of both will be more attractive to you. So what is a singly linked list? So there are two, doubly and singly. And in a singly linked list, as you can see, we start up with a head, and this head points to a node. So a node here, as you can see, in a singly linked list has two parts, a value, which is 5 here, and then a pointer. So as you can see, the arrow on the right would be coming out of that pointer part of the node, and it points to the next node, not to the value of the next node. No, it points to the next node. So basically what this thing is, this node, it has a value and a pointer, which is basically the next node. You could think of it like that. And then the next node itself, again, has a value, of course, and also a pointer. So basically the next node and so on. And yeah, so as you can see, you could be running through this and you could be removing, for example, let's say the node with the value 23. And what would happen is actually it just gets removed and then the pointers would get rearranged. And that's, well, inexpensive to do, or well, inexpensive compared to an array where you have to rearrange all the values. So in a doubly linked list, then here you can see, well, you have an advantage over the singly linked list, actually, if you need this, of course. Here you have a hat again, and then you have 2 pointers. One that says nil or null currently. That means, well, it has no pointer to the hat because you wouldn't do that. You start from the left and go to the right. That's how you read this. And on the right side, you see a previous one, which works exactly as the same as with the hat. The last one actually is null too and doesn't point to the previous. That's just because those are the 2 directions. And then it works exactly like the, well, singly linked list. You can imagine it exactly like that. And you have just access from anywhere to the previous and the next one. And that's, well, the advantage of the doubly linked list then, compared to the singly linked list. And as a conclusion, an array, well, you want to use an array if you want to take care of the memory, because a linked list has a value and a pointer in a node, so that's heavier. And random access by index needed. Well, that means, as I have explained, if you just want to access an element anywhere in the array, you just can use its address and you can access that. And there's actually some math behind it, not just, I don't know, just number 4 or null for the first one. No, it is actually some math. And know how many items will be in an array. Well, you don't have to do that. As I said, in many modern programming languages, this is, well, there's more space for your array at the start, and it just gets rearranged. I mean, computers can handle it. It's just more expensive than a linked list. And then the linked list itself is good for adding values constant time. That means you want to add values constantly, which is good for computing because, well, you don't really want to access anything by random or so with an index. So that is a pretty good thing about the linked list then, if you need exactly that. Removing values from the middle. I've explained that. It's just that the pointers get rearranged and not the whole, well, elements. Every single element is in the array. When you remove something out of the middle, all the ones that follow have to get rearranged by -1. And that's quite heavy. That's quite expensive to do. And then the next one, unknown how many elements. That's good because, as I said, in an array, well, the memory has to be managed. So that means the array needs some space, and if it's too much in the array, it just gets copied into a bigger, in an array with more space in the memory, and that's also more expensive. So meaning a linked list would be better if you don't know how many elements are actually going to be in that, let's just call it box for now. So yeah, basically that was it already. So if you have any questions regarding this, feel free to leave a comment below. I just wanted to make a short video about this. This is not how it works completely. That's just the idea and the concept behind it, really shortly explained. So you have an idea of what data structures actually are. There's much more to it than just linked lists and arrays. But if you're interested about this, just look up in the internet if there's any course online that you find interesting, and yeah, get started with computer science, and if you haven't already, and data structures. So thank you again. Leave a rating if you haven't, and subscribe as well if you haven't yet. And I'll see you in the next video. Thank you. Bye bye.